Hello, today we are going to study Kirchhoff's voltage law, KVL. But before we study Kirchhoff's voltage law, you must know what is voltage rise and voltage drop. The concept of voltage rise and voltage drop in the circuits. For a voltage source, suppose we have a voltage source of value V and our assumed direction of current is such that it enters through the negative terminal of the source and leaves through the positive terminal. We call it voltage rise. And if our assumed direction of current is such that it enters through the positive terminal and leaves through the negative terminal of the source, the voltage source, we call it voltage drop. Whereas in the resistors there will always be a voltage drop, and we know that the end through which the current enters is positive and the other end is negative. Suppose in order to apply Kirchhoff's voltage law to a sample circuit containing, suppose, 3 resistors and a voltage source V, whereas these 3 resistors we call them as R1, R2 and R3, and our assumed direction of current is, suppose, clockwise. We can write KVL equation for this circuit as, suppose we take voltage rise as negative. Let's suppose voltage rise as negative and all voltage drops as positive. So we can write KVL equation for this circuit. So assumed direction of current enters through the negative terminal of the voltage source, therefore we call it negative V, plus the voltage drop across to the resistor R1, that is R1, plus the voltage drop across to the resistor R2, IR2 plus IR3 equals 0. It shows that this is the voltage rise, therefore having a negative sign, like I explained to you, and these 3 are voltage drops, therefore having a positive sign. So we can calculate from this simple equation. We can calculate current as V over R1 plus R2 plus R3. For another circuit having, suppose, 2 voltage sources and 2 resistors, like V1, 2, R1 and R2. Right, we can assume some current I through this loop, and this is we can write equation for this circuit like minus V1, because this is voltage rise. Original direction of current is such that it enters through the negative terminal of the source. Plus IR1, the voltage drop across R1, plus the voltage drop across R2, plus the voltage drop across V2, since the current enters through this voltage source V2 such that it enters through the positive terminal and leaves from the negative, therefore this is voltage drop. So therefore the sign is positive sign. Through this circuit, current can be written as V2 minus V1 over R1 plus R2. It's the last example. We can have voltage source V1, resistor R1, another resistor R2 the loop, and dependent source. Maybe this is 3 times I, where I is the current through the loop. So again we can write KVL equation for this circuit. Just assume a current I through the loop, minus V1, that is the voltage rise in source V1, independent source V1, plus IR1 plus IR2 plus the voltage drop across this dependent voltage source. Since the current enters through the positive terminal, therefore there is a voltage drop, that is plus 3I is equal to 0, right? So now we can find the current through the loop, that is V1 over R1 plus R2 plus 3. So this is how we can apply Kirchhoff's voltage law to a simple series circuit containing one source, two sources, and which can be dependent sources as well as independent sources, and the same concept can be extended to the circuit containing more resistors and more voltage sources. Thank you.